going to solve LeetCode again. Today's question is we are using Python. It's actually an easy question, so let's do this. So today's question is logo rate limiter. This is an easy question. Let's take a look at the problem. So design a logo system that receives a stream of messages along with their timestamps. Each unique message should only be printed at most every 10 seconds. So that is to say, a message printed at timestamp T will prevent other identical messages from being printed until timestamp T plus 10. Unique question. And then all messages will come in chronological order. Several messages may arrive at the same timestamp. Okay. Implement the logo class. Logo initializes the logo object. Boolean should print message with the argument timestamp and message. This method returns true if the message should be printed in the given timestamp, otherwise returns false. So basically this LeetCode question is testing us whether we can do the object-oriented programming, because they want to test us. Can you make the logo class and make the object, and can you implement the specific methods which is required in this question? So let's take a look at the example. Oh! So as usual, I'm gonna take a copy of this and then paste here. I'm gonna make it bigger, and I think it's bigger enough. So this question is logo rate limiter, and then this is the example. So let's take a look at the one by one. So in this question, we are going to initialize the logo object at the first step, and then after that we are receiving the sequence of data which is a pair of timestamp and messages, and then we are supposed to return those true and false. So take a look at that. So a timestamp, maybe time, and then we're going to have a message. So I'm going to take a look at the one by one. So timestamp one, we receive 4, and then we are supposed to return true, because we can do that because previous timestamp we don't have any data, and then we've never seen 4, so it's a new message. So this is just a unique message that we can print. But because we have a requirement that this message is going to prevent other identical messages from being printed until timestamp T plus 10. So this means that we are going to print 4 at the timestamp 1, and then timestamp 2, we keep printing 4 because that's the requirement. So which means timestamp 3, we keep printing 4, printing, and then we have to basically continue this until some time. And where is some time? So the question is T plus 10. So 1 plus 10 is 11. So until T plus 10. So, and it says at most every 10 seconds. So 10 seconds we printed 4, but in the end, timestamp 11, we eventually can print 4. So I'm going to keep it empty, just suggesting that this timestamp we are allowed to print 4 finally. Going to the second data. So second data is timestamp 2. We are going to print bar. Can we do that? We can do that. It is because we never seen bar yet. So here we can return true. this means that we are going to keep printing bar for the next 10 seconds. So, which means that we keep printing, and then timestamp 2, we are allowed to print bar again. So I'm going to keep it empty here, going to the next message. So timestamp 3, we're receiving 4, timestamp 3, but this is the range that we already shown printed the 4. So the message always to be unique. So we are not allowed to print 4 again. So we have to return false. Go to the next data. The timestamp 8, the bar. We look at the timestamp 8, but this is still we already printed bar. So we see bar, but we have to return false. Go to the next data. Timestamp 10, 4. We've already printed 4, and timestamp 10. That's still the time range that we cannot print. So this is also 4. And then we are going to take looking at the last data, which is 11 and 4, which means that timestamp 11, this is empty. So we are allowed to print 4. So we return true. So that's the question, and also the answer we are supposed to return. So now we are going to think about how we can design the solution to this question. So design. So what we have to do is first of all, we just receive data, receive message, and then we're using the what message we receiving and when we receiving the message. So we have to record message and timestamp, because this is the key information that we can do the algorithm. And then after we recorded this, we have to check that we can print message or not. So that's the kind of key algorithm, and then we just keep repeating this. Receive the message, record the data, judgment, receive the new messages, record it, and judgment. So when we design this, first we have to look at this is how to record those data, and also how we can check that we can do printing. So I'm going to take a look at the one by one. So LeetCode. So we receiving the pair of data, message and timestamp, and also we have the requirement of unique messages. So in that case, hash map or dictionary. That is it's a good approach, because the key of the hash map or dictionary is unique. So key is going to be message, and then value is a timestamp. Now, for example, this means that we are going to make a dictionary, because in this question we want to solve by using Python. So we receive 4, and then if that's the timestamp 1, we just record 1, and then if the next message we receive bar, we are recording the timestamp, for example, 2. So we record this kind of data. So that's it for record. And then the second point, which is a check. So we are thinking how to check we can do that. So what we have to do is this thing. So we record the first message and timestamp, and we experience something, and then finally we can say we can print it. So what's happening here is we have current timestamp, and then we are going to compare this with recorded timestamp, and the timing we can print it is 1 plus 10 is 11. So if the current timestamp is greater than or equal to previous recorded timestamp plus 10, we can do that. And then here, for example, here, this is less than 1 plus 10, so we can return false. So what we have to do is just make an if condition, current timestamp is greater or equal to recorded timestamp plus 10. And if that's the case, we can print it. But important thing is so when we print something here, we are experiencing another at most every 10 seconds requirement, which means that at timestamp 12, we start doing the same procedure, and this is going to additional 10 seconds. So the thing we don't have to, we should not forget about is after we decide we can print something, we have to update timestamp in record. So that's the kind of key step that we should not forget about. So at this point, I think we can move on to code those algorithms. So I'm gonna start editing this code. So the requirement of the question is we have to initialize, we have to make a local class, and so initialize, we have to make a init and also implement those methods. So I'm making that. So we are making the local class, and then we have to have initialization. Then we implement the method should print message, should print the message, and then this has a two argument, timestamp and message, timestamp and message. So we're gonna make it this. So at the initialization, we haven't received the data such as the pair of timestamp and message. So what we can do is we just initialize the data set with empty. So we want to use the dictionary, so just initialize dictionary with empty. So from here, we can actually make the algorithm of these designs. So what we have to do is, so first the map is empty, and then we are adding the key messages alongside we receiving the new messages. So what we have to do is if current message is not in the key set of the dictionary, we have to add that. So what we have to do is self map, and I'm adding the new message, and then we have to record the timestamp to the dictionary. So basically we face the new message, so that means we definitely can print this message because this is new, so we are going to just return true. And then after this sequence is the timing when we already seen those messages, but we have to make a judgment whether we can print this message or not. So that's the algorithm that we have to implement is this. So what we have to do is if current timestamp, which is timestamp, is greater than or equal to recorded timestamp, which is in the map dictionary, we are getting that timestamp by message plus 10. And in that case, we can print this. So we have to return true. but we cannot forget about this updating the timestamp in the record. So what we have to do is we're going to record, we're going to update map with the specific message with the new timestamp. Okay. So otherwise, the message is something we've already seen, and also is the time range that we cannot print the same message. So we just return false. Okay, false. So I think this point we can test this logger class. So I want to use the test using this. So just test, paste it. I'm gonna make it list. Okay. And then I have to make a logger object. So I'm gonna make a logger by logger class. And then using logger class methods that we just implemented should print message. But the test is the sequence of data, so we have to use a for loop, and then that's the pair of timestamp and message that's in the test. And then every time we receive timestamp and message, we're going to print the result. This method using the timestamp and message. Okay, so I think we can run this. I don't want to have yellow wave line, so I'm going to run this. It's quite quick. So we receive TTFFFT. Let's check the answer. The answer is TTFFFT. TTFFFT, that's the same. So do we have another example? No, we don't have. So I think we can copy and paste this code to the LeetCode console. Check whether we can pass the question. Run it, submit it, get the result. So today we use Python and we solve the LeetCode question that was actually the easy question. This time we use the Python dictionary, and also we implemented several if statements to solve the question. So that's it for today. Thank you for watching.